All right, hello everyone, and welcome to perhaps my favorite topic of the year. Okay, so today we're going to talk about something called recursion. I'm going to start with a question. If you write a method, can that method call another method? And the answer to that is obviously yes, right? So I just gave an example here. I just wrote an absolute value method. You have a positive number returns x, you have a negative number returns negative x. And then I have another method named abs difference, which is just going to return the absolute value of the two of them subtracted. And we can see, of course, that it's very easy, right? It just calls that method. Okay, but what recursion is recursion is a method which can call itself. So instead of calling another method, the method calls itself. And as for why you might ever want to do this, this is kind of an alternative to for and while loops. So while a lot of things are easier using a loop like we've been doing all along, there are actually some programs, we'll see some examples today, that are way easier to do recursively. So just the strategy for what recursion is you typically want to use this when you have a function that can be defined in terms of itself. Can be defined in terms of itself. So mathematically, you might see this like, say f of x is equal to f of x minus 1. Where like that's just an example where a function f is defined in terms of x. But I think maybe a more straightforward example would be something like factorial. Okay, so as you guys may or may not remember from your math classes, if we take the factorial of a number, so say like 4 factorial. 4 factorial, we write that as 4 times 3 times 2 times 1. So we just multiply everything down until we get to 1, and we multiply them together and get 24. That's great. But you can also define a factorial in terms of a factorial. So an astute observer might recognize that 3 times 2 times 1, oh, that's just 3 factorial. So 4 factorial is actually just 4 times 3 factorial. Okay, and you could even go a step further, right? Because 3 factorial is 3 times 2 times 1, which is actually just 3 times 2 factorial. So if you wanted, you could write this as 4 factorial would be 4 times 3 times 2 factorial. Okay, just kind of replace the 3 factorial with 2 factorial, and you could keep going, right? You could do 4 factorial is 4 times 3. Oh, wow, I can't believe I screwed that up. 4 factorial is 4 times 3 times 2 times 1 factorial. And we can write 1 factorial as 1 times 0 factorial. But then we stop. Still going on this trial, I guess. So then we stop at this point. So 0 factorial is the stopping point. 0 factorial is just 1. But the important thing about this, again, is that I am defining a factorial in terms of a factorial. 4 factorial is equal to 4 times 3 factorial. And then I have some place to stop. And these are the two parts that every recursive method that you write is going to need. So when you write a recursive method, you need to have two things. A recursive method must have. It's going to need to have a recursive call. So that's the point where you call it itself, where the method calls itself. And then the second thing that it needs to have is a base case. And what a base case is it's basically a point where you stop. So instead of just going on forever and going to, like 0 times negative 1 factorial, negative 1 times negative 2 factorial, we just stop at this case where 0 factorial is equal to 1. One other way to kind of think about the base case as stopping point is it's kind of like the simplest possible case. It's the simplest possible case. So 0 factorial is just equal to 1. That's like your stopping point. Okay, so let's go ahead and do some coding. We've talked about kind of the theory and the idea here, but I want to actually do some coding. So let's go ahead and write some recursive methods. And we will start with this factorial method that we just did. Okay, so when we write this, let's just do a public static int for a factorial of some int n. Okay, and what this method is supposed to do is this method will return n factorial. And just as a reminder from what we did just before, n factorial is equal to n times n minus 1. factorial. That's what we talked about before, how like 4 factorial here is just equal to 4 times 3 factorial. And one tip that I want to give you is when you think of like an equal sign in these definitions, an equals is in math is what the function returns. So when I call n factorial, that's equal to n times n minus 1 factorial, that's what I'm going to return. So I'm going to return n times the factorial of n minus 1. So that's like my basic definition of this. So when I call factorial 4, it returns 4 times factorial of 3. Okay, now let's talk about the base case first. So this is my recursive call, that n factorial equals n times n minus 1 factorial. Okay, now we also need our stopping point, and the base case, that's where we stop. That must go first in the method. It must be the very first point of the method, and usually it's going to be an if statement. So if that n is equal to 0, then what I'm just going to do is I'm going to return 1. Okay, so it's a stopping point because I'm not doing any more recursion. I'm just returning a number. So if I call factorial 0, it will just automatically return the value of 1. Okay, now let's test this out and make sure it works in a couple different cases. And you can see that if we just stop this, so without this, the recursion will go forever. Right, you'll do factorial 3, and then factorial 2, factorial 1, factorial 0, factorial negative 1, factorial negative, and it'll just go forever. I'll show you that in a minute. Okay, so let's go ahead and try this out. So when we call factorial of 4, hopefully it returns 24, and it did. Oh, cool. Okay, and let's talk about like why it's returning 24. And we talked about this kind of in the math terms, but now let's go ahead and talk about it in computer science terms. So when I call factorial of 4, what that does is that returns, okay, so I go back to my code, and that's going to return, okay, 4 is not 0, so it goes here. So that's going to return 4 times factorial of 3. And again, when I have this returns, think if this is just like an equal statement. It's saying like factorial 4 equals 4 times factorial 3. And now let's go down the chain. So what is factorial 3? So factorial 3, so we go in here again. Is 3 0? No. So it does 3 times factorial of 2. Okay. Is 2 0? No. So then we go to the next case. So factorial 2 is equal to and gets replaced with 2 times factorial of 1. Okay, and then factorial 1 is equal to 1 times factorial 0. Okay, and now let's trace this backwards. Whoa, that's not what I wanted. So here, when I do factorial 0, I'm going to get to this point where I call factorial 0. And this is the point in my code where when I have factorial 0, n is 0, it just replaces that with a 1. So what's happening in my code is this part, let's use a different color, this part just gets replaced with a 1. So factorial 1, and then it kind of works its way backwards. So once we have factorial 1, so this part now, factorial 1 just gets replaced with 1. So that's 2 times 1. So this is 2 times 1. So then factorial 2 is equal to 2 times 1, so that gets replaced with 2. 3 times 2 is equal to 6. So factorial 3 we can replace with 6. So that's why this just returns 24. So basically, when we have this like factorial 3, and we know that that's returning, that's equal to 3 times factorial of 2, eventually that just gets replaced with 3 times 2. So it just gets replaced with 6. So it kind of builds this chain of method calls. And when it gets to the bottom, it resolves, okay, factorial 0 is 1, I'm going to replace that with a 1. Okay, now factorial 1 is 1, so that's 2 times 1 right here. And then that's 3 times 2. Okay, so that factorial 3 just gets replaced with a 6. So think of the returns as an equal sign and what it's equal to. So when we say factorial 3 equals 6, we just replace it with a 6, kind of substitute it back in. So that's how this is working, and that's how this happens. Now, if this keeps going, right, this would be like 0 times factorial of negative 1, negative 1 times, and that would just get in an infinite loop. So what we'll see is, let's comment it out and see what that looks like. Okay, so when I comment that out, and I try and run this code now, we're going to see it get stuck in an infinite recursion, kind of like an infinite loop, and eventually it just gives me this error. where my computer, you can see, is really freaking out, and just stop it. You can stop it, of course, in the normal spot here, but it tells you to Stack Overflow error. You may have heard of the website Stack Overflow. A Stack Overflow error is just an infinite recursion. And that gives you a Stack Overflow error. And again, that's just like having an infinite loop. It's the same thing. Okay, cool. So that's what's going on. Let me give you one more example here. I'm going to give you a short bit of code. I already wrote this method. So I want you to think of really quickly, what does this method do? So what is going on with this method, and what does it return if I call dog of 4? All right, so go ahead and pause the video, do that on your own. Okay, so now let's go ahead and let's run through an example. And this kind of tracing the code out, this is what you'll have to do on the real AP test. So when you run this, okay, so when you call dog of 4, it's going to look at this. And okay, is 4 less than 1? Yes, so then it's going to go through the else. And you might notice, like, you could have an else. I wrote my factorial without an else, but you can put an else in if you want, if that makes more sense to you. So in this case, we look at this and says, okay, 4 is not 1, so this is going to return. So when I call dog of 4, that's going to, I don't know why I spelled that dag. That's going to return 2 times 4 plus dog of 3. Okay, 4 minus 1 is 3. So now I go backwards. Is 3 less than or equal to 1? No. So dog of 3. So now my x is 3. It's basically called this method again, and now my x is 3. So now when I do this, this is my new value of x. So that's going to be 2 times 3 plus, and now I'm going to call dog of 2. And then when I call dog of 2 again, it's recalling the method. Now x is 2. So 2 is not less than or equal to 1, so it goes down here. So it replaces dog of 2. Remember, the returns is like an equal. We're substituting it. So dog of 2 gets replaced with 2 times 2 plus dog of 1. Okay, so at this point, dog of 1, 1 is less than or equal to 1. So at that point, we'll just go ahead and return a, oops, in this case, we'll return a 2. That's the base case. So now it just kind of goes ahead and adds these together. So it does 2 times 4, which is 8, plus. And dog of 3 is 6, plus. Dog of 2 is 4, plus. And then dog of 1 is just a 2. Okay, so now it just adds those together. So hopefully this should return 20. Let's check it and make sure. So when I call this method dog, I'm going to send it to 4 and return to the 20 value. Okay, great. So that's what we expected. All right, and that's just kind of the code tracing that you want to do. When you solve these problems, you want to write this kind of stuff out just as I've done. All right, well, guys, thank you so much for watching. I'll have a little more examples in the next video.